This is a hands-on class, so open the lab guide and run the commands with me. So far in this course, you have mastered the Linux command line and shell scripting and A212, the skills for operating and automating a system. Today, we add the single most important tool in all of modern software development, Git, a version control system. If there is one tool every developer, every DevOps engineer, every serious technical person on earth uses daily, it is Git. Think of Git as a time machine for your work. It remembers every version of your files, so you can go back to any point in the past. It lets many people work on the same project at the same time without stepping on each other. And it means you can change anything fearlessly, knowing that nothing is ever truly lost. And A212. If a change goes wrong, you simply return to a version that worked. Before version control, people saved files like aneka tt20, report final, aneka tt20. Git solves all of that elegantly. Today you will learn what version control is, what Git is, the three areas it moves your changes through, commits and history, branches for parallel work, and how to share your work with others through push and pull. By the end, you will be making real commits. Let us begin. Here is what we will build today. First, why version control matters. Second, what Git actually is. Third, the three areas Git uses. Fourth, commits and history. Fifth, branches. And sixth, remotes and at412, pushing and pulling. Let us begin. Let us start with the problem version control solves. Because once you feel the problem, the solution is obvious and wonderful. Version control is a system that records every change made to your files over time. Instead of your project being just its current state and A212, whatever the files happen to say right now and A212, it becomes a full history. Every edit, when it was made, who made it, and why. Nothing that was ever saved is forgotten. Your project gains a memory, a complete timeline of how it came to be what it is. That memory gives you three superpowers. First, you can see exactly what changed between any 2 points and A212, what was added, removed, or altered, and A212, which is invaluable for understanding and for finding when a bug crept in. Second, you can go back and A212, return your project to any earlier version instantly if something breaks or you change your mind. And third, and most transformative, many people can work on the same project at once, and version control merges their changes together intelligently, so no one overwrites anyone else on 100 onion byte ace work. Compare that to life without it. Emailing files back and forth, folders full of Andy 200, 200, 200, 200, final 8200, final 8200, final v200, final v200, Andy 200 or fine, copies, and the constant terror that a change will break something with no way back. Version control replaces all of that fear and chaos with confidence and order. You edit freely because every version is safe, you collaborate smoothly because changes merge instead of collide, and you understand your project and Tree 9's whole story because it is all recorded. This is why version control is not optional in professional software and A212. It is the foundation everything else rests on. So the takeaway? Version control records every change to your files over time, giving your project a full history, an A212, so you can see exactly what changed, roll back to any earlier version, and let many people collaborate without overriding each other, replacing the chaos of NA220, final V2 and A225's files with confidence and order. Version control is the concept. Git is the specific tool, and it is the one the entire software world has settled on. Let us understand what makes it tick. The first key idea is that Git works with snapshots, not just differences. Each time you save a version, NATE12, a commit, NATE12, Git essentially takes a complete snapshot of your whole project at that moment and stores it. Your history becomes a series of these snapshots, like frames in a film. This makes going back to any past version simple and reliable. Git just restores that snapshot. It is a robust, straightforward model, an A212. Your project and ITS timeline is a sequence of complete saved states you can return to at will. The second key idea is that Git is distributed. When you copy a Git project, an 8012 file called cloning an 8012 file, you do not just get the latest files, you get the entire history, the whole set of snapshots, on your own machine. Every developer has a full, complete copy of everything. This means you can work entirely offline with full access to your history, and there is no single fragile central copy whose loss would be catastrophic and A200 The history exists in full on every machine. It makes Git fast, resilient, and independent. Together, these make Git powerful and trustworthy. It is snapshot-based, so your versions are complete and restorable, and it is distributed, so the full history lives everywhere, and you are never dependent on being online or on one central server. Git was created to handle one of the largest software projects in the world and A12, the Linux kernel and A2012. And that heritage shows in how well it scales from a solo hobby project to thousands of developers. Learn Git once, and it serves you at every scale for the rest of your career. So the takeaway, Git is the version control system almost everyone uses. Built on two ideas and A200, it stores complete snapshots of your project at each commit, making any version restorable, and it is distributed. So cloning gives every developer the entire history on their own machine, making Git fast, resilient, and usable offline. Before we make changes, we need the thing Git tracks, the repository. A repository and 8.12, almost always shortened to repo and 8.200, is simply a project folder that Git is watching. It is an ordinary directory of your files, plus a hidden record that Git keeps of the entire history of everything in it. When people say NA2021, the repo NA2020 hunt, they mean the project together with its full Git history NA20 the files and their story, bundled as one. Everything you do in Git happens inside a repository. Turning a folder into a repository is a single command, git init, run inside that folder. That command creates the hidden Git record, and from that moment on, Git is tracking that folder and 80/100 while watching every file you add, edit, or delete inside it. Ready to save versions whenever you tell it to. Before git init, a folder is just files. After git init, it is a repository with a memory. It is the starting line for everything else. There are two common ways you get a repository in practice. You either run git init to start a brand new one from an existing folder of your own, or you clone an existing repository and A2112, copying someone else and retain S repo with its full history down to your machine, which is how you join an existing project. Either way, you end up with a local repository on your computer that Git is tracking, and that is your workspace for everything that follows. In Today in 39 S Lab, you will git init a fresh folder and watch it become a repo. So the takeaway, a repository or repo is a project folder that Git is tracking and A212 your files plus the hidden record of their entire history and A212, and you create one by running git init in a folder or by cloning an existing repo, giving you a local workspace with a full memory of every change. Git is a concept that, once it clicks, makes all of Git make sense. Your changes move through three areas on their way into history. The first area is the working directory. This is just your project folder as you see and edit it, an 8012 file, the actual files you open, change, and save in your editor. When you modify a file, that change lives here first, in the working directory. It is your live workspace, the current state of your files, where all your editing happens. Git sees these changes, but has not yet been told to do anything with them. The second area is the staging area. This is a holding zone where you gather the specific changes you want to include in your next save. You move a change from the working directory into staging with the command git add. Why middle step? Because it lets you choose precisely what goes into each commit and A12 You might have edited 5 files, but only want to save 3 of them together as one logical change. Staging is where you assemble exactly the set of changes for your next snapshot, deliberately, rather than saving everything indiscriminately. The third area is the repository itself and A212 the permanent committed history. When you run git commit, everything currently in the staging area is saved as a new snapshot in the repository in ION 2209's history permanently. So the flow is a clear 3-step pipeline. You edit in the working directory, you git add the changes you want into the staging area, and you git commit to save them into the repository forever. Working directory, staging area, repository, and 81.2 edit, add, commit. This little pipeline is the beating heart of using Git, and once you internalize it, every Git command finds its place. So the takeaway? Your changes flow through 3 areas: and 81.2 the working directory where you edit, the staging area where git add gathers exactly the changes you want, and the repository where git commit saves them permanently, and 81.2. So the core rhythm of Git is simply edit, add, commit. Let us zoom in on the commit because it is the fundamental unit of everything in Git and A200 all. The individual frame in your project and A2 Selenium as film. The rhythm is 2 commands. First, git add stages the changes you want to save, and A200 you are selecting what goes into this snapshot. Then, git commit takes everything staged and records it as a permanent snapshot in your history. Crucially, each commit carries a message, an A252 or 5, a short line you write describing what this change does, like an A220 add login form, an A220 or an A220 fix date bug, an A220 fix date bug, an A220 self and your teammates about why this snapshot exists. As you work, you build up a sequence of commits, and that sequence is your history and A212, a complete, ordered timeline of every saved state of the project, each with its message explaining what changed and why. This history is permanent and always available. You can look back through it to see how the project evolved, read the messages to understand the reasoning behind past changes, and pinpoint exactly which commit introduced a particular feature, an 812 or a particular bug. And because every commit is a full snapshot you can return to, this history is also your safety net and your undo button. Made a change that broke things? Go back to the last commit that worked. Want to see what the project looked like last week? Check out that commit. The commit history turns your project into something you can navigate through time freely and safely. Now this is why good commit habits matter so much. Commit often in small logical pieces with clear messages and 8200, because a clean history is a gift to everyone who reads it later, including you. Each commit is a checkpoint you can always return to. So the takeaway, a commit is a permanent snapshot created by git add, then git commit, each carrying a message explaining the change at OI200 pool, and the sequence of commits is your history, a navigable, ever-available timeline that lets you understand how the project evolved. Find where a bug was introduced and return to any working version. Now one of Git in 39. See most powerful features. The one that makes true teamwork possible, branches. A branch is a separate, independent line of work. Imagine your project entasa, main history, as a trunk, and a branch as a limb growing off it, where you can make changes without affecting the trunk. UN 8-2020, branch often 8-2021 to work on something, and 8-2012, a new feature, a bug fix, an experiment 8-2020, and all your commits go onto that branch, leaving the main line completely untouched and stable while you work. It is a private sandbox that shares the project N3D9 history up to the point you branched. Why is this so valuable? Because it lets you work on something new without any risk of breaking the working code that everyone relies on. The main branch stays solid and functional. Your half-finished feature lives safely on its own branch until it is actually ready. You can experiment boldly, make mistakes, and iterate all in isolation. And when your feature is complete and tested, you merge the branch back into the main line, and A212 Git combines your changes into the chunk, and now the feature is part of the project. This is exactly how teams work in parallel without chaos. Each person or each feature gets its own branch, everyone works simultaneously on their own branches, isolated from each other, and merges their finished work back into the main line when it is ready and ATI 212. With Git intelligently combining everyone and IT. No one blocks anyone else. No one, any 5 half-done work, breaks the shared code, and the main branch stays reliably working at all times. Branching and merging is the core workflow of essentially every software team on Earth. Master it, and you can collaborate on any project at any scale. So the takeaway, a branch is a separate line of work where you can commit freely without touching the stable main line. Then merge back when your feature is ready and 8.212, which lets you experiment safely and lets whole teams work in parallel on their own branches without breaking each other. 209. S work or the shared main branch. We have been working locally on our own machine. The final piece is sharing that work with others and with a backup in the cloud through remotes. A remote is a shared copy of your repository that lives somewhere central and 8200, most commonly on a hosting service like GitHub. Everyone on the team has their own local copy on their machine, and they all connect to this one shared remote to exchange their work. The remote is the common meeting point, the version of the project that the whole team synchronizes against, and a safe backup living off your own computer. You interact with the remote through 2 mirror image commands. Git push sends your local commits up to the remote and 85p do over. You have made some commits on your machine, and push-in publishes them to the shared copy so others can get them. Git pull does the reverse. It brings down commits that others have pushed to the remote, updating your local copy with everyone else. And tidy 9's latest work. Push sends your work up. Pull brings others and 9 mine work down. That simple up and down exchange is how a distributed team stays in sync. This completes the picture of collaboration. You work locally and 8.200, editing, staging, committing, branching, and 8.200 entirely on your own machine. Then you push to share what you have done and pull to receive what others have done, keeping everyone and precise copies in harmony through the shared remote. The everyday rhythm becomes pull the latest changes before you start, do your work in commits, and push when you are ready to share. Combined with branches, this is the complete workflow of modern software teams, from 2 people to 2,000. And services like GitHub add a whole collaborative layer on top, and 8.200, reviewing each other, and 8.200. But it all rests on this foundation of push and pull. So the takeaway? A remote is a shared copy of the repo, usually on a service like GitHub, that the whole team synchronizes against, and 8.2.1.12. Git push sends your commits up to it, and Git pull brings others in 3.9 commits down. So you work locally and then push to share and pull to receive, keeping every copy in sync. Let us close with the habits that make Git a pleasure rather than a source of confusion. Because how you use Git matters as much as knowing the commands. First, commit often in small logical chunks with clear messages. Resist the urge to make one giant commit at the end of a long day. Instead, commit each meaningful, self-contained change on its own, and 8.201, add 8.201, add the login button, 8.201, fix the date format, and 8.201. Fix the date format and 8.201 with a message that clearly says what it does. Small, frequent, well-described commits make your history readable, make it easy to find and undo a specific change, and are a genuine kindness to anyone who reads the history later, yourself very much included. Second, pull before you start and pull before you push. Because others are pushing their changes to the remote, your local copy drifts out of date. Pulling first and 8.212 at the start of your work session, and again right before you push, and 8.212 keeps you in sync with everyone else and dramatically reduces conflicts. It is a small habit that prevents most of the merge headaches beginners run into. Stay current and collaboration stays smooth. And third, use a branch for each feature and keep your main branch always working. Never do risky or unfinished work directly on main, branch off, do the work there, and merge back only when it is ready and tested. This guarantees that main any 82 forward The branch everyone depends on any A2 fault is always in a functional state. Commit often with clear messages, pull to stay in sync, and branch to protect main. These three habits turn Git from something you fight into something that quietly makes your work safer and your team faster. In the lab, you would practice exactly this rhythm. So, the takeaway, use Git well with 3 habits and A2 control. Commit often in small logical chunks with clear messages, pull before you start and before you push to stay in sync and avoid conflicts. And use a branch per feature while keeping main always working and only to a tool, turning Git into a tool that makes your work safer and your team faster. Let us gather the whole class in one breath. Version control records every change over time and OA tool fine so you can review history, roll back, and collaborate safely. Git saves complete snapshots and is distributed, so everyone holds the whole history on their machine. A repo is a folder Git tracks, started with git init or by cloning. Changes flow through 3 areas and A212, working directory, staging via git add, and repository via git commit. Commits are saved snapshots with messages that form your history. Branches let you work in parallel and merge back. And remotes, like GitHub, are the shared copy and A1212. Push sends your commits up, pull brings others and OR down. Next class, NA12, CICD, automating build, test, and deploy. One idea at a time. That is, Git and